Hello, welcome back. Today we're going to be talking about writing equations and inequalities. By the end of today, or this video, you should be able to know how to write equations and inequalities from a verbal model or situation, and you should know how to write a verbal model from an equation or inequality. So in other words, we're going to be going from equations to the verbal models, and then we're going to be going from the verbal models to the equations. To get started on this first objective, let's take a look at a few vocabulary words that are going to be essential to understanding, again, this first objective. Okay, for the first word, we have the word expression. Variables and or constants linked by operations. Let me give you some examples. 2x is an expression. 3x minus 5 is an expression. X is an expression. 2 is an expression. X to the third is an expression. In other words, we have letters and numbers being linked together by addition, subtraction, multiplication, division, or exponents, or we just have a plain letter, such as x, or just a number. So an equation is two expressions linked by an equal sign. So I could take any of these two expressions, link them by an equal sign, and I'll get an equation. Let's look at an example. 2x equals 3x minus 5. I linked two expressions with an equal sign, and that created an equation. I could have also gone x equal to 2. Again, two expressions, x and 2, linked by an equal sign. An inequality are two expressions linked by the one of the following signs: less than, greater than, less than or equal to, or greater than or equal to. Notice the equal to signs show up underneath the less than or the greater than, the little line on the bottom, to indicate that the number can also be equal to the given amount. Let's look at an example. I can go 2 is less than 4x minus 7. And that would be an example of an inequality, because I linked two expressions, 2 and 4x minus 7, with my inequality symbol, less than. Alright, let's take a look at that first objective a little bit more closely. In order to talk about that first objective, we need to define a few words and how they show up inside of equations. The first words we want to look at are words that mean equals. Words that mean equals are the same as, equal to, the to be verbs, am, is, are, was, and were, in a sentence. So, Sam is 2 feet taller than George. Somehow, we need to turn this statement into an equation. To do that, we might turn it into a verbal model first. So we know the is from the previous statement. Words that mean equals. Is a word that means equals. So we're going to use the equals symbol for the word is. And I know that Sam is or equals 2 feet taller than George. 2 feet taller. That would be 2 plus George's height. Now that's a perfectly valid verbal model. What we would want to do from here is see if we can shorten it a little bit by making our variables a little smaller. So we would call Sam, at least you could, S, and we call George G. So we have an equation now from our sentence. Sam is 2 feet taller than George. S is equal to 2 plus G. Okay, words that mean less than. Words that mean less than is fewer than. Notice that there is an is also inside of less than, but it's followed by fewer than, which means that we're going to have a less than symbol. Let's look at an example. The amount of money in your bank account is fewer than $100. The words is fewer than means we're going to have a less than symbol. Since $100 follows is fewer than, we're going to put $100 right here. Now we just know that the amount in our bank, so amount. The amount in the bank is less than $100. I'm going to call that A. So A is less than 100. So for the last example, I'm going to write it up here. You get a text message that you have fewer than 10 megabytes left for internet usage. Well, fewer than means we're going to use the less than symbol. And we have fewer than 10 megabytes. So we know we have less than 10 megabytes left. Next thing we need to do is assign a variable to what we actually have 10 less than. And we have less than 10, rather, megabytes of internet usage left, so I'm going to call that I. So my inequality, you could have used a different variable, is internet usage, or I, is less than 10 megabytes. So I is less than. Let's take a look at some words that mean greater than. Greater than means is more than. So we're going to looking for amounts that are more than something. Our first statement is a number is greater than 5. So is greater than means we have the greater than symbol. And than what? Than 5. All we need to do now is label a number as a variable. So I'm going to call a number just n. N is greater than 5. So we've written an inequality from our sentence. Words that means less than or equal to. Is at most, that's one of them. Is no more than is another. So your friend tells you that there are at most 10 restaurants in his hometown. Write an inequality for your friend's statement. So we know that at most means less than or equal to. Well, let's think about what is less than or equal to. We know there are less than or equal to 10 restaurants, so it needs to be less than or equal to 10. What's less than or equal to 10? The number of what? Oh, okay, the number of restaurants are less than or equal to 10. All right, we're on to our last two types of statements, words that mean greater than or equal to, and we're going to have some combined statements down below. Words that mean greater than or equal to are is at least and is no less than. I should say than. Let's look at an example. There are at least 2,000 students in Colleyville Heritage High School. So the words are at least means greater than or equal to. And the amount that's greater than or equal to on the right-hand side would be 2,000. We know there are greater than or equal to 2,000 of something. What's greater than or equal to? The number of students, which I'm going to call S. So the number of students are greater than or equal to 2,000. Combined statement examples. Suppose a number is greater than 5, so n is greater than 5, but no more than 10. So we know that n is also no more than 10, so it has to be less than or equal to 10. Because the words no more than means less than or equal to. This is a bit tricky, but how do you think you would combine greater than 5 and less than or equal to 10? Because our number has to be between those two values. It has to be bigger than 5, and it has to be less than or equal to 10. If you notice, those two values are pretty continuous, meaning from 5 to 10. And we know that n is in between those two values. So I can say n is less than or equal to 10. Now here's the weird part. N is greater than 5. Notice, the 5 is at the little pointy end of that symbol right there, meaning the 5 is at the smaller end, or 5 is less than n, and n is greater than 5. So we can actually read our symbols two different directions. So 5 is less than n, which is less than or equal to 10, turns this combined statement into one inequality. Since this one's a bit more tricky, I'd like you to try the one down below by pausing the video, working it out, and then pressing play to see the answer. Okay, x is at least negative 2. So x is at least means greater than or equal to negative 2. And less than 0, so we know that x is less than 0. On a number line, it would be negative 2. And then 0 would be over here. And we know that x has to be in between, because it has to be bigger than negative 2, bigger than or equal to, and it also has to be less than 0. So there you've written a combined inequality from the statement. There is a word of caution when using these statements, and that word of caution is below. Be careful. What does 5 less than 10 mean? Well, if you'll think back to when we did the expressions we wrote last video, 5 less than 10 means 10 minus 5 because we've taken 10 and we've made it less 5 amount. So 5 less than 10. What is 5 is less than 10 mean? Notice that is ridiculously large and in a different color. I'm pointing out something. The word is, again, means that there's going to be an equation or inequality. So 5 is less than 10 means that 5 is less than, exactly how we read it, is less than 10. Notice these two things are completely different. So the word is very important. Okay, I now have a few practice problems for you to work on your own. Notice these are worded a little bit differently than a lot of the problems we did previously. That's because it's linking together what we did last video along with what we're doing this video, which is writing equations along with writing expressions from last video. What I'd like you to do is try to work out the first two. Press play to see the first two answers. If you got them right, go ahead and pause the video, work out the rest, then check your answers. If you got them wrong, figure out what you did wrong, fix that mistake, and then work one example at a time. But please make sure you're working these examples to make sure you understand what you're doing before you proceed on in the video. Okay, let's take a look at that first example. The difference of twice the number k and 8 is 12. So the difference of twice the number and k would be twice k minus 8, and it is 12. The product of 6 and a number n is less than 24, so product meaning we're going to multiply 6 and a number, and it's less than 24. 6 less than x is 10. Now this one's trying to trick you. 6 less than x means you go x minus 6, and it is 10. The sum of 42 and a number, n, is equal to 51. So 42 plus n is equal to 51. The product of 8 and a number k is greater than 4. So 8k is greater than 4. Okay, now is your chance to try actually writing the verbal rule or the verbal expression or equation from the actual math. So you're going to have to turn x plus 8 equals 13 into a statement. 15 minus y, 4y, something 6 into a statement. So go ahead and try to write out the words for these three examples, and then if you feel up to it, these two are kind of challenging, so try to work these two examples as well, and then you can press play to see the answers. Okay, let's take a look at that first example. The sum of x and 8 is equal to 13, or you could have also written x plus 8 equals 13, which is a lot faster to write. The second one could have gotten the difference of 15, and the product of 4 and y is greater than 6, or 15 minus the quantity 4 times y is less than 6. Let's take a look at the next couple of examples. 2 is less than or equal to 7 less than the product of 3 and x. Or you could have said 2 is at most 7 less than the product of 3 and x. For the more challenging problems, the product of 9 and the quantity 5 more than a number t is less than 6. Anytime you see those words, the quantity of or the quantity, that usually indicates there's going to be some parentheses, since we're multiplying 9 times the quantity of 5 more than a number t. So 9 is being multiplied by the quantity of 5 more than a number t, and that's less than 6. The last one's similar. The product of 3. So we're going to multiply 3 by a difference. So 3 is being multiplied by this entire difference of 6 and 4, or 6 and f, and it's equal to 4. You could also say the product of 3 and the quantity, again the quantity indicating there's going to be parentheses, 6 less than f is 4. Last one is the product of 3 and the quantity f minus 6 is 4. So again, the word quantity indicates that we're going to put f minus 4, or f minus 6 rather, in parentheses.